Hello guys, in this video we're going to have another example on the quadratic pole or zero or basically second order h of omega. That's a little bit sophisticated. That's why I called this video or the name of this video ugly example on like second order filters or second order, Bode plots. Okay. Let's see how to solve this. First we have to put h of omega in a standard form. Okay. So we know from before, like there are some standard form, like simple zero, simple ball, like quadratic zero or ball. So looks like this guy here is similar to simple zero. What was the standard form of a similar zero? 1 plus j omega over omega c to the power of n. N here is equal to 2, clearly, but it's not, we don't know omega c yet. And that guy here looks similar to quadratic second order, like quadratic ball. Okay, with n equal to -1. Okay, or n equal to 1 if like because it's a ball. Okay. Again, it's not clear because a formal standard form of that quadratic ball is 1 plus j omega over omega c square plus j 2 theta omega over omega c. But it's not clear again. Here we have 1, here we have 300. So we have to convert. We have to convert, that shape into these standard forms. Okay, so let's do that. So h of omega. So in the numerator, we have to take 30 as a common factor. 30, and we're going to end up with 1 plus j 10 omega over 30, and all of that is squared. Okay. And in the denominator, we have to take 300 as a common factor. Okay. So we're going to end up with 1 minus 3 over 300 square plus j 90 over 300 omega. Can I continue simplify this? So that's a 30 square plus 1 j 10 omega over 30, it's omega over 3. Omega over 3 square. And down here we have 300. 1, yeah. Okay, we get the 1. Now how to get this one? And also we get this guy, it's like this guy, so it's okay. Now it's only this square term, okay? So we have minus, and we have here positive. But remember, -1 is basically j square, right? That's plus j square, omega square. And the 3 over 300 is basically 100. And the 100 is 10 to the power of 2, right? So we can have here 10 to the power of 2. Plus j 90 over 300. 90 over 300 is basically 3 over 10. Okay, 3 omega over 10. Just to make it simplification yourself, it's going to be like that. Okay, good. Okay, let's continue. So 330 square, 30 square is like 30 multiplied by 30. 30 by 300 is basically 10, and 10 by the 30 is basically 3. So that will be 3, 1 plus j. Let's do it in like 3 terms. So we're gonna have the 3 like a constant, and then 1 plus j omega over 3 square. Then the third term is basically the denominator, okay? So we're gonna bring it to the numerator with -1 as exponent. So it's 1 plus then j omega over 10, and that's all square. J square, omega square, 10 square, that's all of that square. Plus j 3 omega over 10. And now let's, to the power of -1, of course. Now let's compare, okay? So if we have like, let's go back to the color here. So that guy here is similar to that guy, okay, with omega c equal to 10, equal to 3. And this guy here equal or similar to this one with omega c equal to 10. And you can deduce that from that term or that term, and they have the same omega. They must have the same, okay? And 2 zeta equal to 3, and from that, zeta is equal to 1.5. Okay, good. That's a simple 0 with n equal to 2. That's a quadratic Bode, and n is equal to -1. Okay, and that's basically a constant. So when we draw that, we have to draw the 20 log. So 20, continue with the same color that we started with. So 20 log the magnitude, we also draw the magnitude of h of omega equal to 20 log 3 plus 20 log the magnitude of 1 plus j omega over 3 square minus, because this -1 here will be minus, so minus 20 log the magnitude of 1 plus j omega over 10 square plus j3 omega over 10. Okay, let's continue simplification. 20 log 3, that's a constant. It's around 9.5 decibels. Okay, plus we're gonna bring the 2 here, so that will be 40 log. And let's do, the magnitude, which is 1 square plus omega over 3 square minus 20 log the magnitude log, and the magnitude of all of that with the square root of the real part square plus the imaginary part square. This is the real part, by the way. Although there is a j there, but this j, remember, it's squared. So j squared is -1. So it's a real, right? So 1 plus j over omega over 10 and all this is plus the imaginary part square 3 omega over 10. Okay. Good, 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 good. We're so close. Now let's have like a dash like that. Separate between these two. Okay, that's a constant. So it will be something like that. At 9.5 distance. Okay, that's omega. That's basically the y-axis. Okay. Now for the term in the middle. Okay, we learned that before. We have two cases. Number one, when omega over 3 much less than 1. We're gonna neglect that guy, so that will be 40 log 1. Log 1 is 0, so that's 0. Number 2, when omega over 3, or omega c basically equal to 3, much larger than 1, we're gonna neglect the 1 this time. So it will be 40 log omega over 3. So when omega over equal to 3, which is the omega c, that will be log 1. Log 1 is 0, so that will be omega equal to 30. That will be log 10. 10 is 1. That will be 40. Omega equal to 300, which is 100 omega c. That will be 80, and so on. Okay, so that something will be something like that. Rho versus omega at omega c, which is 3. Before omega c, we have 0. And after omega c, we're going to have something like that with 40 decibels per decade. That's not the final drawing. I'm just, showing you what it will be. We're going to draw in details after like 2 minutes or something. Now for that part, okay, is the last term, which is the quadratic function, or the quadratic like Bode. Okay. So again, we studied before. It has also two cases. Number one, when omega over 10, which is omega c, omega much tended to be 0, which is basically much less than 1. That's fine. Okay. Or omega over omega 10 much less than 1. In that case here, gonna be to -20 log 1, which is basically 0. Number two, when omega over 10 tended to be infinity or very high, very high. When omega increases, okay, much more than 10, okay. In that case, we're going to have two approximations. Number one, we're going to neglect the one to the omegas, to any term that has omegas, okay. So one will be much less than omega over 10. And in that case, the first approximation will be log square root of omega over 10 squared. Then another square, there are two squares there, plus 3 omega over 10. The second approximation is as follows. Remember, this guy here is omega to the power of 4. We'll have omega to the power of 4. This guy here will have omega to the power of 2. And if omega over 10 tends to be infinity, omega to the power of 4 will be much higher than omega squared. So we can neglect that term. So that another second approximation, minus 20 log square root of 2 squares omega over 10 square. Simplifying that, minus 20. I'm going to do it very details. Square root of this second square here. Now it's first square. J square is minus 1 and omega square and 10 to the power of 2. Where is that again? It will be minus 20 log. Minus 1 square is 1. That's omega to the power of 4 over 10 to the power of 4. That's finally 20 log omega 2 omega square over 10 square. We can still approximate it to, or not approximate now, equal to minus 40 because 2 omega over 10 to the power of 2, 2 to the 20 will be minus 40 log omega over 10. And again, okay, if omega equal to omega c, which is 10, that will be 0. Omega equal to 100 or 10 omega c, which is 100, that will give us 100, that will give us minus 40. Omega equal to square, which is basically 1000, that's minus 80. Omega equal to 1000 omega c, which is 10,000, that will be minus 20 decibels, and so on. Minus 120, minus 120. So that will be something like that. Let's draw it. H omega. So at omega, before omega c is 10. Before 10, it's 0. Then after 10, it will be going down like that. Okay? And that's minus 40 decibels per decade. So we're going to have 3 straight lines. We're going to add them together. Okay? Go back to the black here, black line, black ink, and have very long. Okay, and be a little bit ugly because the omega c's are different. We have omega c equal to 3, another omega c equal to 10. So that's 10, 100, 1000, about 4, about 5, and that's 100. Let's start by the easiest, the constant. So the constant was 0, for example. Yeah, let's continue the text. Yeah, let's have this 10, 20, 30, 40, 60, and 80, minus 10, minus 20, minus 40. Oh, we have to have the same scale. 10, 20 is in 30, minus 40, minus 50, 60, 70, and 80. Minus 70, minus 80. Okay, the green. Let's have, yeah, the green. Let's so 9.5 decibels. That's a constant line from minus infinity to infinity. Okay. So it's approximately 10. So I'm gonna like, because anyway it's approximation, I'm gonna make it at 10 because it's easier because we have a line drawn already. So that's number one. That's the 9.5 this. Okay. Then with another color, let's have, the with this line. With number two. Number two, we have when it's less than 3. No, let's do, okay, because this is 3. Let's do the 10 first because it's ugly. So with this one here, the third one. When it's less than 10, 0, so that's the 10. So we have 0 here. Then after 10, we have that. When 10 is equal to omega equal to 10, we have 0. Omega equal to 100, we have minus 40. Minus 40. There you go. Omega equal to 1000, we have minus 80. That's 1000, and that's minus 80. We can stop at that because it's going to be a lot. So, and that's here minus 40 decibels per decade. That's the slope. Each decade, like from 1 to 10, from 10 to 100, that's a decade. The value by minus 40. Finally, the ugly one. So we're going to draw it, for example, with this one, light blue. Okay. So here we, until 3, when omega over omega less than 3, much less than 3, we have 0. For example, that's the 3. We have now another scale, 3, like 30, 100, 1,000, 30,000, and so on. Okay, 30, 300,000. Less than 3, we have a 0. So we have 0. After 3, at 3, we have 0 again. And then we have at 30, we have 40. At 300, we have 80. And you can stop. That's number 3 here. Okay. Good. That's number 1, number 2, number 3. Third. Now we should add them together. That's the ugliest thing we're gonna do today. Do it with dark blue. Okay. Before 3, we have 0. Sky blue, we have 0 purple, or magenta, whatever this color is, and we have 9.5 decibels again. So it will, until here, it will be all 9.5. The final value is dark blue. Then between 3, I'm sorry, and 10, still the purple is 0, but we have now a line, straight line going like that with 40 decibels per decade plus 9.5. So what's going to happen is that this line will be shifted up. Okay, why? Because it's again going to be straight line. So 0 plus 9.5 will be 9.5. Then here we have this value, whatever it is, and we're going to add to it 9.5. So it will be, for example, here. So basically, this line will be shifted up like that, parallel, like that. Okay, that's still 40 decibels per decade. Still. Now, after the 10, or at the 10 and after, we have a line going up with 40 decibel per decade, and another line started from 0 with minus 40 decibel, minus 40 decibel per decade. So that guy here is 9.5. This is 9.5 decibel plus 40 decibel per decade. But this guy is only, it's like 0 minus 40 decibel per decade. So what's going to happen? When we add this to this, the 40 decibel minus 40 decibel go with the 40 decibel, and we're going to end up with like the 9.5. So basically what's going to happen, we're going to continue constant like that. Okay, so that's the final Bode plot. And what is that? That's a high pass filter. High pass filter. And it's ugly. Why it's ugly? Because there is no tens, or hundreds. It's still like 3 and 10 here. It's not like so smooth. Okay, guys, that was it for this, example. Thank you very much for watching and see you next time. Bye-bye.